Okay, folks, so last couple of days we've been talking about scatter plots and lines of fit, correlation coefficients, and positive and negative and strong and weak correlations. So we're going to continue on that and on a related topic, and today we're going to talk about correlation versus causation, okay? So I have a pretty funny little comic for you here today. This guy's saying that everybody who went to the moon has eaten chicken, probably because the astronauts who walked on the moon were given chicken in their meals. And this guy's saying, good grief, chicken makes you go to the moon. Obviously, that is ridiculous, okay? Because chicken doesn't make you go to the moon, right? One doesn't cause the other, right? But they are correlated because they sent chicken into space with the astronauts to eat. So, open that up to the second page here. All right, so correlation and causation. When a change in one variable causes a change in another variable, it is called causation. Causation produces a strong correlation between the two variables. We know all these, or we know at least the word correlation, right? The converse, or the opposite, is not true. In other words, correlation does not imply causation. So in other words, correlation means, sorry about the typo right there, that two variables are just related to each other, okay? Correlation means that they are related in some way, okay? On the other hand, causation means that one thing will cause the other, right? The x variable causes the y variable to happen. So you may have correlation without causation in the chicken and walking on the moon instance, but you may not have causation without correlation, right? So if you have causation, that means you have to have correlation. So in the next three situations, right, you're going to tell whether a correlation is likely in the situations to the right, and if so, you're going to tell whether there is a causal relationship, and I want you to explain your explain your reasoning, okay? All right, so is the time spent exercising and the number of calories burned, is there a correlation between those two things? I would say yes. There is a correlation between those two things. If I could actually write here, correlation, right? And I would say that there is correlation as well, that there is causation as well, because the more time you spend exercising, right, the number of calories you are going to burn, right? Time spent exercising causes the number of calories burned to go up. And so there is causation between these two, okay? The number of banks in the population of a city. Well, it makes sense that the more people you have in a city, the more banks you have, just because, you know, they have to have bank accounts. But it doesn't mean that just by building banks, you're going to have more people in a city, right? So you could build as many banks as you wanted, but that doesn't necessarily mean that the population of the city is going to go up, right? So I'd say, yes, there's correlation. But the one isn't going to cause the others. So the one isn't going to cause the other, so that there is no causation. So it is not a causal relationship. Okay. Last one: time spent playing video games and your GPA. I don't know. I could argue, or I could see that there's definitely can be a correlation between these two. But I don't know if one necessarily causes the other. In some arguments, maybe you could say that more time spent playing video games decreases your grade point average, just because you're not spending time studying. But I don't think that it's a direct relationship. I don't think it's as easy as that. So I would say that there can be a correlation, but there is not necessarily causation. And that's the end of this first video for you guys.